Welcome, pre-cal students, to the homework help video, page 483. Let's go ahead and get started with the lesson today, or the homework help video, and here we go. Numbers 1 through 7, I believe it says to type these into your calculator and come up with an answer. So here we go. For number 1, we would do this. We would type in the log of 7 divided by the log of 3. Okay, so here we go. Log of 7, close the parentheses, divided by log of 3, and you will get 1.771. Number 3, you would type into your calculator the log of the argument, which is 4, and divided by the log of 1/2. Now don't forget to close your parentheses, students. When you type in log of 4, then close your parentheses, divide it by log of 1/2, and then close your parentheses, okay? And you will get -2 for your answer. -2. Okay, moving on to number 5. Number 5, you would type into your calculator, this is 1, 3. For number 5, you would type into your calculator log of 0.4 divided by log of 9. Okay, so here we go, log 0.4. Close the parentheses, divided by log of 9, and you will get -0.4170. All right. Moving on to number 7. Number 7, you would type in log of 1,250 divided by the log of 15. And let's see what you would get here. Log of 1,250. Close the parentheses, divided by log of 15. And you will get 2.633. Okay? 2.633. There we go. Okay, moving on to number 9. Okay, number 23. Now we're going to expand a bunch of these, okay? I think it's numbers 23 through 41, I believe. Okay, so here we go. Let me get a drink of water here. We'll get started. Let's expand this, okay? So notice that your argument is multiplying 5 times x. So that means you can write your log base 10 twice and put a plus sign in between them. And we'll have the log of 5 plus the log of x. Now, by the way, you don't have to put these 10s if you don't want to. Remember, guys, when it's the base 10, it's understood to be there. So you're welcome to write the base 10 if you want to, but you don't have to. Okay? So there's your answer. Number 25. Okay, we have an argument here that's being divided. So we're going to put log base 10, log base 10, y base 10 because the base 10 here, and then we're going to subtract these two. Okay, subtract. So here we go, the log of 5 minus the log of x. The top always comes first, the bottom comes second, and you do not need the base 10 if you don't want those. You're welcome to put them, but you don't have to. Okay, moving on to number 27. Okay, we have x to the 4th power. Well, we have learned whenever your argument has a power, you can move it to the left. So your answer would simply be 4 log base 8 of x. Okay, and moving on. I keep pausing, students. I'm checking the answers as we go, okay, to make sure that we're doing these correctly. Okay, number 29. Well, don't forget that the square root is the same thing as the 1/2 power. So you really have the natural log of z to the 1/2 power, because there's a 1 here and a 2 here. So z to the 1/2. Well, the 1/2 can go to the left, so your final answer is 1/2 natural log of z. Okay? All right, moving on to number 31. Now here we have three variables being multiplied. Okay? X times y times z. So we're going to write the natural log 3 times. And we're going to add all of these, okay? So the natural log of x plus the natural log of y plus the natural log of z. That's it, guys. It doesn't get any easier than that, okay? All right, moving on to number 33. All right, now, here's what we have, guys. Be very careful on this, okay? We have the natural log of parentheses a minus 1 to the 1/2 power. Because this entire expression here on the inside is to the 1 power. Anything is to the 1 power. And I have a 2 right here. Okay? Now, I can take the exponent and move it to the left. So I have 1/2, and please do not, students, drop the parentheses. You cannot drop the parentheses. Okay, that is what you're taking the logarithm of. This entire thing, okay? And that's as far as you can go. There's nothing else you can do, students. Okay? Now, if they were multiplying, then you could split it up into 2 logs. If they were dividing the a and the 1, then you could split them up into 2 logs. But they're not. They're subtracting. So there's nothing else you can do. Okay, that's as far as you can go. All right, number 35. Okay, first of all, notice we have a product. And you're like, we do? Yeah, we do. Look, natural log of z times z minus 1 squared. So I'm going to write 2 logarithms and put a plus sign, okay? So natural log of z plus the natural log of z minus 1. Z minus 1 squared. And now this 2 goes right here. So my final answer is natural log of z plus 2 natural log of z minus 1. Booyah. Here we go. Done. Moving on to number 37. Okay, now look, the exponent of the x is 1 and the exponent of the y is 1. So you really have the natural log of x to the 1/3 over y to the 1/3. Now you have you have an argument that's being divided. You have an argument that is a quotient. So I'm going to write the natural log once, and then again, then put a minus sign. Okay? And the top comes first. The bottom comes second. And then remember, powers can be written to the left. Okay, so I would have 1/3 natural log of x minus 1/3 natural log of y. Here we go. Very good. Moving on. Let me check that in the back of the book real quick. Yep, moving on to number 39. All right, now be very careful here. First of all, get rid of your quotient, okay? You have a whole numerator and a whole denominator, okay? So I'm going to write the natural log twice because we have a quotient in my argument, okay? Put a plus sign here, so the natural log of the top, which is x to the 4th, y to the 1/2. If you don't mind, I'm going to go ahead and take the liberty to put y to the 1/2, okay? There's a 2 here and a 1 here. Okay, so y to the 1/2. And the natural log of z to the 5th. Now, z to the 5th, yes, I'm going to move this right here. That's fine. But here I have a product, x times y. So I'm going to split this up here into 2 logarithms. So I'm going to put natural log, and then plus, and then bring this down, 5 natural log of z. Okay? Now here I'm going to put x to the 4th plus the natural log of y to the 1/2. And then to save time, guys, I'm just going to get a little sloppy here. Cross that off and put a 4 right here. And cross this off and put a 1/2 right here. Okay? Let me check the back of the book and make sure that's right. Kind of squeeze this plus sign over here a little bit right here. All right, there we go. Number 39. Back of the book says, yep, the exact same thing. Actually, my fault, guys. I'm sorry. You guys probably caught this. This should be a minus sign, shouldn't it? This right here should be a minus sign. So sorry about that. There we go. And there we go. All right, number 41. Okay, again, we have a quotient. So let's go ahead and take care of the quotient first. So log base b, log base b. Numerator comes first, minus this. Now, yes, we know we're going to do this. That's fine. Oh, students, be careful, please. We're going to take this logarithm here, and we're going to split it up into 2 logs because y and z are multiplying. But guys, listen, there's a minus sign right here, and that minus sign goes to the entire log. So, if you're going to split this log up into 2 logs, you've got to put parentheses around them. Because this minus sign here that I'm bringing down goes to the whole expression. Please don't forget that, okay? Very important. Okay, so log, write your logarithm twice. Log base b, okay? And your y squared goes here. They're multiplying, so put a plus sign. And then z cubed. Okay? Now, risking being a little sloppy here, I'm going to take this and slide it here. And take this. And slide it here. Okay? So your final answer, now you can leave it like this, I suppose. I would really like you to multiply the negative sign through. I really would. So 2 log base b of x minus 2 log base b of y minus 3 log base b of z. Okay, let me check the back of the book real quick here, make sure that we're accurate. No little mistakes are being made, and we are good. Moving on to 43. Okay, numbers 43 through, let me look here. It looks like 43 through maybe 63. We're going to condense these down to 1 log. Okay, so now we're going backwards, okay? So look, you must have the same base, and we do. Base E, so we're good, okay? And we're adding 2 logs. Well, when we're adding 2 logs, we can write that as 1 log as long as we multiply this argument times this argument here. So your argument would be 3x. Natural log of 3x. Now, students, you are more than welcome to put parentheses. That's fine. But you don't need to, because whenever it's a product, whenever they're multiplying, we already know they're one term. Now, if there was a plus sign here, and you were taking the logarithm of the entire expression, then you would have to put parentheses, okay? So when it's a product, you're welcome to put the parentheses, but you don't have to. Okay, it's totally up to you. Okay, number 45. Okay, 2 logarithms that are being subtracted. They have the same base. So we're going to put log base 4. And the first argument goes up top. And the second argument goes at the bottom. So there we go. I better check the back of the book on these past 2. I did not check the book. I always want to do that to watch for little mistakes. Okay, this one was good, and this one was also good. Okay, moving on to number 47. Okay, well, this one here looks a little tricky. Look at it, your argument is not dividing, and it's not multiplying. So what are we going to do? Well, we can at least take this 2 and move it out here as an exponent. And I believe that's all they want you to do. I'll check the answer key in a second, but I think that's all they want you to do. And some students could argue, is it really condensing? Well, I mean, it is. You know, it's not that much, but it is. Okay, number 49. Okay, let's see here. All they want you to do is move the 1/4 to here. So we have log base 3 of, now the 1/4 goes to the entire argument, okay? So in this case, you would want to put parentheses around it because of the exponent, okay? Now, in the end, they really want you to do this. I would like you to do this also, okay? 1/4 power means the 4th root. So there we go. That's really, and I'll try to remind you of that on tests and quizzes. That's really how far you want to take it, okay? All right, number 49 is correct. Number 51. Okay, we're subtracting 2 logs. Now, students, listen, before you put them together as 1 logarithm, you never want a number out front like this. Or in other words, you never want a number to the left of the logarithm when you start writing them as 1 log. So this 3 here should be gone, and it goes right here. Now we're ready. Please don't forget, let me go over that again. You do not want to start writing 2 logarithms as 1 logarithm when there's a number to the left or a number to the left, okay? So we're going to move this right here, and now we're good to go. Now we're subtracting 2 logarithms. So we write 1 log, up top is x, in the bottom is x plus 1 to the 3rd power. And that's it. That's as far as we can take it, okay? All right, number 53. This one's pretty cut and dried, pretty simple. We're subtracting 2 logarithms. There's no number to the left here. No number to the left here. So we're going to put 1 logarithm. This one goes up top, and this one here goes in the bottom. And that should be it. Let me check the back of the book real quick on that. Yes, that is correct. Okay, number 55. Okay, now students, look. You do not want to start split writing this as one logarithm until you've taken this 4 right here and multiplied it through. Okay, we want to simplify as far as we can before we start writing these as one log. So here we go. Negative 4 times this logarithm is negative 4. Natural log of x plus 2. And then negative 4 times this would be negative 4. Natural log of x minus 2. Okay? There. Now let's be really, really careful here, guys, okay? First of all, let's go left to right. Okay, left to right. So, well, actually, first of all, I'm going to take this 4 here and move it to here, okay? And take this 4 here. Like I've taught you guys, you never want a number to the left of the logarithm, okay? When you're trying to write them as one logarithm, okay? Now, make these minus signs real good and long here. Okay, let's go left to right. Left to right, here we go. We have 2 logarithms that are being subtracted. So write your logarithm once. Okay, write your logarithm once. Your first argument goes up top. Your second argument goes to the bottom. Okay, and then bring this down, minus this thing here. How's that for good math language? This thing here, okay? Now we're going to combine these two, okay? So watch carefully what we do here, all right? We're going to put natural log, and then this goes up top right here. I'm going to put it over here. We'll have to do some simplifying to it. So this here goes up top. And this goes in the bottom. Okay, let's put this over 1. Now you guys know what to do. We take this fraction, we flip it, and we multiply it times the top. So we end up with this right here for our answer. X times 1 is x. And x plus 2 to the 4th power times x minus 2 to the 4th power gives you this right here. There's no way I want you to work all that out. That'd be crazy. Okay? And that is your final answer right there. Okay? Let me check the back of the book real quick and make sure we're right on that. And they're showing for some reason, oh, they went ahead and multiplied these together. We're not going to do that. That's totally sufficient right there. Okay, totally fine. All right, number 57. Okay, let's go ahead and take our 1/3 and multiply it through. We're going to have 2/3. Natural log of x plus 3 plus 1/3 natural log of x minus 1/3 natural log of x squared minus 1. Okay? Now, obviously, the 2/3 is going to go up here as a power. The 1/3 here will go as the power of the x, and then the 1/3 here will go as the power. And now we're doing the whole thing, same thing again. So here we go, guys, okay? These two are being multiplied together. So, natural log of x plus 3 to the 2/3 power times x to the 1/3. Okay? So I took this argument here, this argument here, and I multiplied them because the 2 logarithms are being added. So I multiplied my 2 arguments together. Okay, moving on. Now, bring this down. Now I have 2 logarithms that are being subtracted. So write your natural log, and this goes up top right here. Okay? And to be honest, students, that's good enough for me. Now, I don't mind a step further. Okay, here's what the back of the book, they had this. They said to write a cubed root like this because they're all, they all have a denominator of 3. And so leave the x plus 3 to the second power. That 2 right here comes from this 2 right here. And then x to the 1/3, or x to the 3rd, x to the 1. And you do not need to put that 1 if you don't want to. All over x squared minus 1 to the 1 power, which you don't need to put that if you don't want to. So you could just leave it like this. Okay, and there we go. Okay, so I'd accept either one of these. I really would. I prefer this one here. Okay, all right, number 59. Okay, here we go again. Multiply your 1/3 through 1/3 natural log of y plus 2/3 natural log of y plus 4 minus natural log of y minus 1. Now notice, students, the 1/3 only goes to this logarithm here and this one here, not this one over here, because of the brackets. Right here, the brackets. Okay? Alright, moving on. Now, let's go ahead and move our 1/3 and our 2/3 here. So, these two are multiplying here. So natural log of y to the 1/3 times y plus 4 to the 2/3. And then bring this down here. Okay, so we have this whole logarithm here minus this logarithm here. So natural log of y to the 1/3 y plus 4 to the 2/3 all over y minus 1. Now notice, students, your numerator here has this whole top of your argument here has a 3 here and a 3 here. So I would really like you to learn to do stuff like this. I would write the numerator like this. Natural log cubed root of just the numerator y to the 1 power, which you don't need to put that 1 if you don't want to. This 1 here is from this 1 here, okay? And then y plus 4 to the second power, coming from this 2 right here, okay? All over y minus 1. And the y minus 1 is not under the radical, okay? Let me check the back of the book real quick. Make sure we didn't make a little mistake anywhere. And I would have to take issue with the back of the book. They're putting the y minus 1 under the radical. That is totally incorrect, unless I'm missing something somewhere, and I'm positive about this, students. I am totally positive the 1/3 goes here and here, not to here. And so I'm trying to see where I made a mistake at. I don't see any, so this is correct right here. Number 61. Okay, here we go. Take your 1/2 and multiply it through. So we have 1/2 natural log of x plus 3 plus 1/2 natural log of x minus 3. And then minus natural log of x squared minus 9. Okay, students, moving on to number 61. 61. Here we go. Okay, we already did. My fault. We already did all this. Okay. Um. Okay. Let's move the 1/2 here to the exponent to a power. Let's move the 1/2 here as a power. There we go. And now we have two logarithms here being added together. Okay, so we're at the logarithm once, and we have x plus 3 to the 1/2 power times x minus 3 to the 1/2 power. Now, to be honest with you students, I want to pause here for a second and show you something that you need to see. Okay, so look carefully at this. Look, let's go ahead and, if this is to the 1/3 power, and this is to the 1/3 power like this, do understand that we can do a little simplifying here, okay? Let me show you. You can actually multiply these two together and get x squared minus 9 to the 1/2 power. Let me show you how, okay? Remember, this to the 1/2 power, x plus 3 to the 1/2 power is the same thing as the square root of x plus 3. And this, x minus 3 to the 1/2 power, is the same thing as the square root of x minus 3. So, you can multiply those two together, and they'll be to the 1/2 power. Okay, so you can do that. It's totally fine, guys. Let's look at it again, okay? You have a radical times a radical. Okay? So when you multiply them together, you would get the square root of x squared minus 9, which is the exact same thing as this right here. X squared minus 9 in parentheses to the 1/2 power. Minus natural log of x squared minus 9. Okay? There we go. Now, they're being subtracted. So natural log of x squared minus 9 to the 1/2 power over x squared minus 9. Okay? Now for the final answer, I would put this right here in a radical. So natural log of square root of x squared minus 9 all over x squared minus 9. Okay, that does check. Let's move on to number 63. Number 63. Okay, here we go. I would first of all encourage you to write this as x squared minus 4 to the 1/2 power. Okay? And cross this off. Okay? Okay, here we go. Two logarithms being added. There's no number to the left, and there's no number to the left here. So, we have natural log of x plus 2 times x minus 2. We should know from algebra that's a really quick multiplication problem. It would be x squared minus 4. Okay? So there we go. And then bring this down over here. Okay? Now next, we're subtracting two logarithms. So write your logarithm once, and your x squared minus 4 will go up top over x squared minus 4 to the 1/2. Now, guys, look, I'm looking right now in the back of the book, and I see what they have, and I understand it, okay? I guess it all comes down to how far I want you guys to take these problems. This is okay, and to be honest, the 1/2 is a square root. And I really don't want you to have to rationalize a denominator. It's a lot of work, okay? So I'm okay with this. But listen, let me show you something that's really cool here, okay? Look, guys, let me ask you a question. If I had x to the 5th over x to the fourth. You guys have learned from Algebra 2 that you can subtract the exponents when you're dividing. So 5 minus 4 is 1, so this equals what? X to the 1 power, right? You took 5 minus 4, you wrote the base one time right here, and you subtracted the 5 minus the 4. Well, let's do the same thing over here. Look at this. If I put this in parentheses and put it to the what power? The 1? Look what you have. You have a matching base and a matching base. The base here is x squared minus 4, and the base here is x squared minus 4. So write your base once, and then subtract your exponents. 1 minus 1 half will give you 1 half. There. That's the same thing we did over here, guys. Look, whenever your bases are the same, you can subtract the exponents. Well, here's your base, and here's your base. They're the same. So write your base one time and subtract the exponents. 1 minus 1 half is 1 half. And now look what you have. The square root of x squared minus 4. Okay? So I'm okay with this. I really am. This is a little better. This is a little better right here. Okay, moving on. Number 65. Okay. The directions say to state which one of these are equal. Well, these here are not equal. Okay, nowhere have we learned that when you're taking this one here is not equal to this one here. Okay? We have not learned any properties that would support that, okay? However, we have learned this. This here, when two logarithms with the same base are subtracting, you can write them like this and divide the arguments. So these two here are equal. Okay, they're equal. Okay, moving on to number 67. 67. Okay, they want us to solve these, I believe, if possible. So here we go. Let's start with number 67. Okay? Log base 3 of 9 equals x. And I think the direction is to not use a calculator. Let me check. Let me check and make sure here real quick, guys. Hold on 1 second here. Lesson 7.3. I was in the back of my book so I could check the answers. Let me turn over there. Yeah, find the exact value without using a calculator. If it's not possible, then tell why it's not possible. Okay, so here we go. Number 67. Okay, here we go. I set it equal to x, like I've taught you guys to do. Okay, then I wrote this. 9 equals 3 to the x. Okay, and then 9 can be written over here, 3 squared equals 3x. So the answer is 2. X equals 2. Okay, not too bad. Okay, let's try the next one here. Log base 4 of 16 to the 1.2 power equals x. So next I have 16 to the 1.2 power equals 4 to the x power. Okay? I want to write both sides with the same base. Okay? Well, I can write them both with the base 4. So for 16, I'm going to put 4 squared, 1.2, okay? Equals 4 to the x, okay? Multiply these together and you get 4 to the 2.4 equals 4 to the x. Cross off your bases. 2.4 equals x. Okay? So 2.4 is your answer. Let me check that in the back of the book real quick. And we're moving on. Okay, number 71. Log base 3 of negative 9 equals x. So negative 9 equals 3 to the x. And we can stop right now. Never can you take the logarithm of a negative number. Never. So the answer is no solution. Can't be done. Why? Because the argument is negative. Also, if the argument was 0, you cannot do it either. You cannot take the logarithm of 0 or a negative number. And look over here, here's the proof. What number could you put for x that would give you a negative number out like negative 9? There's nothing. If you put a negative number in here like negative 2, that just gives you a fraction. Okay? If you put a positive number in for x, like 5 or 2, that gives you out a 9. But no way, there's no number that you can put in for x that will give you out a negative number over here. Okay? Again, you cannot take the logarithm of a negative number or 0. Okay? Alright, moving on to number 73. Well, first of all, let's condense these two together, okay? You're subtracting two logarithms, so let's put log base 5 of 75 divided by 3, which would be 25. So there we go. So we put these two together, and now let's solve this. So that equal to x, 25 equals 5 to the x. Write both sides with the same base. Cross off your 5's, 2 equals x. So there's the answer, 2. Okay, so 73 is 2. Moving on to number 75. Okay, again, we have two logarithms. They're both base e. Okay, let's go ahead and, to be honest with you guys, this one here would be easier if we just went ahead and solved each logarithm by itself. Log base e of e squared minus log base e of e to the 5th. Now look, guys, natural log means log base e. We learned a property that says whenever your bases match, your answer is the exponent. So this entire logarithm here equals 2. And look, your base here matches your base here. So the entire answer is 5. So you have 2 minus 5. So the entire answer is negative 3. That's pretty easy, okay? Let me say that again. Whenever your base of the log matches the base of your exponent, then the entire expression equals just your exponent. Okay? Alright, so the answer is negative 3. Okay, we check the back of the book like we always do to check for little mistakes, and we're moving on. Okay, you cannot take the logarithm of a negative number, nor can you take the logarithm of 0. Okay, so no solution. No solution. Okay? Alright, this one here, the answer is 4.5. You should see that right away, guys. 4.5. Here's why. Natural log of e is log base e of e to the 4.5. And once again, like we studied number 75, whenever the base matches the base, the entire expression just equals the exponent. So the answer is 4.5. Okay? Alright, number 81. Let me look here what they want us to do real quick. Okay. Use the properties of logarithms to rewrite and simplify. Okay, so we're going to rewrite and simplify. So here we go. This will be interesting. Not sure exactly what they want us to do, but here we go. Let's try this, okay? Well, probably when I see an 8 here and a 4 here, I'm thinking this. Maybe they want us to go log base 4 of what? 4 times 2. We can do that. Okay? 8 is 4 times 2. Right? Now, next I can go like this. Log base 4 of 4 plus log base 4 of 2. Oh, guys, we know this whole thing here equals 1. What's my power right here? 1. Whenever your base matches your base, the entire expression equals the exponent. So 1 plus, now what would this be here? Let's work it out. Let's come over here. Let's come over here and work it out. Log base 4 of 2 equals x. 2 equals 4 to the x, right? I mean, there we go, 4 to the x. So now 2 equals 2 squared to the x. 4 is 2 squared. Next we have 2 equals 2 to the 2x. With the 1 right here, okay? Cross these off and divide both sides by 2. X equals 1/2. Because 1 equals 2x, divide both sides by 2, 1/2 equals x. So this whole expression here equals 1/2. This whole expression here equals 1/2. So 1 plus 1/2, 1 and 1/2, or 3 over 2. Which is what the back of the book has, 3 over 2. Not too bad. I like what they're doing. It was pretty good practice for us. Okay, number 83. Okay, we're going to set this equal to x, okay? Now, next I would have 1 over 250. I think this will work, guys. Maybe not. Let me think this through for a second here. Let's see. Let's do this. Let's put log base 5 of 1 minus log base 5 of 250. Now remember, guys, anytime you take the logarithm of 1, it equals 0. Okay, that's a property that we learned. So the logarithm of 1, I don't care what the base is, the logarithm of 1 is 0. That's gone. 0 minus, now let's solve this over here. This will be pretty easy, guys. $250 equals 5 to the x. And if you'll use your calculators, you'll see 5 to the 4th power equals 250. Okay? Cross off your 5's, 4 equals x. So we have 0 minus 4. The answer is negative 4. Okay, that's number 83. Alright, moving on to the next. You know what? I better make sure. You know what? I'm wrong on that. I'm sorry, guys. I don't know what just happened there. Let me hit escape here. And it's not what I want. Let's do that. Okay, guys, I apologize. It's not right at all. It's so funny that I said that. Okay, hold on 1 second. Let me fix this. Okay, guys, I'm back here. I apologize. I don't know where I got this from. 5 to the 4th is not 250, and I realized that when I got down to the end here. I was like, whoa, that is not right at all. So let's go back up here and let's do this, okay? This is totally correct right here. The logarithm of 1 is 0, okay? That's totally correct. Now, if you'll think about powers of 5, here's what I'm going to do. And I'll show you why I'm doing this later. Okay, I'll show you why later. Log base 5 of 125 times 2. Okay, now I'm going to show you why I'm doing this later. I'm going to take this right here and make it this. So now I have 0 minus, parentheses, log base 5 of 125 plus log base 5 of 2. Now here's why I chose 125. 125 is a power of 5. Okay? So for 125, I can put this. I can put log base 5 of, now look what I put for 125. I put 5 to the 3rd power. Now get Mr. Earhart, where are you getting all this stuff from? Well, guys, I'm just improvising, doing trial and error, just different stuff like that, okay? Whatever I can think of to try to get this thing broken down into bases of 5 and stuff like that. So here, my base here matches my base here. So this entire exponent here, this entire logarithm is 3. So 0 minus 3 plus logarithm base 5 of 2. Now there's nothing you can do with this. Okay, nothing at all. So now take your negative side and multiply it through. 0 minus 3 minus logarithm of 5 base 2. And we don't need the 0, obviously. So 0's gone. And there's your answer. Okay, let me check the back of the book to make sure that's right. And I do apologize for the confusion there on that one. Yes, that is correct, okay? All right, number 85. Number 85. Here we go. Okay, right away, students, I see, like I saw up here, that because I had a base 5 right here, I wanted to somehow write the base with 125, which I could then break down to a power of 5 to the third power. Well, here, look what I have, guys. I have natural log, which is base e of this. And notice I have a base e already right here. So here's what I'm going to do. I'm going to put log base e of 5 plus log base e of e to the 6th. Okay? Because they're being multiplied right here. Now look, your base matches your base, so the entire expression here equals 6. So I have the natural log of 5 plus 6. And I think that's it. Let me look at the back of the book here real quick. Yeah, that's it. They have this for their answer. Either one of these is acceptable, okay? Alright, moving on to numbers 87 through 93. Okay, students, on number 87 through 93, they want us to take this right here, this given year, this given year, and this given year, and solve these logarithms, okay? So here we go. Log base b of 10 would be log base b of 2 times 5. Now I'm choosing 2 times 5 because I know the logarithm of 2 and I know the logarithm of 5. Okay? So here we go. Log base b of 2 plus log base b of 5. Okay? And log base b of 2 is 0.2891 plus the logarithm of 5 is 0.6712. So if we add those together, we get 3, 0 carrier 1, 6 carrier 1. I think I'm getting 0.9603, I believe. Yep, that is correct. Okay, so there is your answer. Okay, moving on to number 89. Okay, number 89. I'm going to rewrite the argument as 2.5 is 2.5. Okay? And 2.5 is 5 over 2. So there we go. Looking pretty good. Log base 5 minus log base of 2. Okay? So there we go. Log base 5 is 0.6712 minus log base b of 2 0.2891. Okay, let me grab my calculator to make sure I don't make a mistake here. And we're getting 0.3821. Okay, 0.3821, and that is correct. Very good. Moving on to number 91. Number 91. Okay, now here, be careful on this. Watch carefully. It's a little confusing, but it's really not too bad if you watch carefully and take some really good notes, okay? First of all, square root of 15b is the square root of, or the log of 15b to the what? 1/2, okay? And then take the 1/2 and we'll put it out front here, okay? So now we have 1/2 brackets log base b of 15 plus log base b of b. Okay, now let's keep going. Okay, now look, 15 is 3 times 5. Okay, so for 15 right here, I'm going to put 3 times 5. And why 3 times 5? Because I know the logarithm of 3 and I know the logarithm of 5. Okay, so here we go. Log base b of 3 plus log base b of 5, okay, plus log base b of b. Now, I have 1/2, okay, and the log of 3 is 0.4582, plus the log of 5 is 0.6712, plus, guys, look, what is the exponent of your b right here? It's a 1. And whenever your bases match, the entire expression equals just the exponent, so I have plus 1. Now with the calculator, I'm going to add these together right here. I'll get 1/2 times 0.4582 plus 0.6712 plus 1. Okay? 2.1294 times 1/2. I'm going to get this for my answer. 1.0647. Now, if that's not the right answer, I'm gonna scream. Okay. Let's see here. Yes, it's the right answer. Okay, good. Moving on to number 93. Number 93. Okay, here we go, students. We have division. So I'm going to write logarithm of b of 25 minus logarithm of 3b. Okay? For the 25, I'm going to put 5 times 5. Okay? Because I know the logarithm of 5. So now I have logarithm base b of 5 plus the logarithm of base b of 5. Okay? I'm adding here because the arguments here are multiplying. Minus this whole expression, log base b of 3, plus log base b of b. Okay? So here we go. Log base b of 5 is 0.6712 plus 0.6712 minus log base b of 3 is 0.4582. And on the last problem, we just saw that your power here is 1. Whenever your bases match your base, the whole expression equals your exponent, and your exponent is 1. So 1 like this. There we go. So we have 0.67 plus 0.6712, which would give you 1.3424 minus, and then here we would have 1.4582 when you add these two together right here, and then subtract these two, and you will get negative 0.1158, and that better be correct, and it is. Okay, good. Alright, guys, I hope this homework video has been a help to y'all. Call or email if you have any questions.